Good evening, sir.
Hey, son, how you doing?
Doing fine, sir. How about you?
I'm not been complaining now. Kind of under the weather, but I'm giving thanks. Could have been worse.
That's good, sir. That's good. Just pull that through.
Yeah, man. Big up yourself, pops.
Good evening, sir. Classmates.
Hey, Alric, what on? Reach out early,
Yeah,
man.
sir.
You're not going to work today?
Yes, sir. I was at work.
Oh, okay. You're reaching early.
Yes, sir. Left work early.
Nice. Love the sound of that.
Uh, sir.
Go.
Yeah. Where do you mean practice? A question.
Mhm.
Trapezoidal rule, and say a question with two other symbol. We call him the S symbol behind
This
that.
is integration.
Yeah.
Uh-huh.
Yes, it's like two like function in one. So
Yeah, that's called a double integration.
so we are gonna do that.
Yeah, man. Come on, my shoe teacher, man.
All right, sir.
Matter of fact, them all have triple one too.
Eh.
Yeah, but I don't think we can do the triple. We just are just gonna go up to the double.
All right, sir.
Yeah, man.
And another thing, we don't see the McLaren series worksheet where they do. You never seen it like
Can't recall, honestly.
yeah, cause me a search for it, me don't see it.
I can't recall McLaren's. I can't recall. I can look to see if I find something, but I can't recall. I can check the our email thread because we just keep
Yeah.
one thread going. So I'm just checking the email thread.
Okay,
But
sir.
normally though, whenever I send something off to him, he posts it.
Yes,
I
sir.
mean,
He posts
yeah,
everything that he sends. So
yeah, man.
I
Right.
just didn't see any, and I know that we did some McLaren series questions and answers. So
Right, no problem.
yeah.
Thanks for the notification.
Yes, sir.
All right. So as we wait on others to join, I know the last time around we looked at some errors and I just want to see if I can find a question for you involving um errors, and if I can't find one, I just have to generate one. All right, so I'll give the others about 7 minutes to come in and we'll start at 10 past. All right.
Okay, sir.
Okay. All right, so what I want you to do now is evaluate that integral using the trapezoidal rule with 4 trapezoids for me. Quick and fast. I'm giving you 10 minutes to do this. Well, yeah, no more than 10 minutes, guys. No more than 10 minutes. So start for me, please. I see more students joining. There are now 11 of you. Let us see. All right, guys, depending on you to go through this pretty quickly. Thanks. All right, we have 3 more minutes. 3 more minutes to finish off, please.
How many decimal places you answer? 2 or 3?
Good question. Give me 2 decimal places.
All right, sir.
Sir, I sent you an answer. Okay. And let me know if it's correct.
Yeah, I'm checking as we speak. Hmm.
Sir, I also sent one.
Yeah, man, I'm seeing all of those at present. Just trying to figure out if it's the same thing that okay. All right, so nobody has got the response that I've gotten. Well, maybe one. All right. So all right. So let me see now. Who has it? I'm not going to, I'm going to say you're wrong. It's when you give me my questions like this, when you're finding your integrations, unit squared. So if you don't give me a unit, it's wrong. So nobody has gotten the answer. I need to get my unit squared. You have to speak the correct jargon. I am concerned. I really need to move on tonight. And so I'm seeing one correct answer just now. Thank you, sir, for putting on your unit squared. Okay, Kahim, I would agree with that one. Am I agreeing fully? Let me just look again. Yeah, I'd agree. Except that 4 is supposed to be a 3. Um, the rest of you,
Sorry, yes, 4 should be a 3.
mhm. The rest of you, I want to look back at the stuff because I'm gonna add a little bit more flavor to this question. Okay, no. All right, sorry. Kahim, um,
Yes, sir.
let it stay. This is your approximation, so let it stay. Don't change it. Let it stay.
Okay.
Mm-hmm. Um, oh my gosh,
Sir,
come.
so my answer wrong.
Mm-hmm.
All right.
Yes, sir. Check the shot, please.
All right. No, I'm agreeing with you.
Oh, my feet, sir.
Yes, sir. I'm
Yes,
calculator, sir. I'm gonna get a new one. It.
And
That's
and
what.
and and, and this is where now I am gonna go off on you students, because when you go into the exam, I'm not going to be there to prompt you to say you're off, go again for you to get the correct answer. So you have to get it in at the first go.
Yes, sir.
And know you know how to do it.
Yeah. Yes, sir. I calculate that, sir. Me get a new one, but it's on the way.
Okay. So I'm not worried that you guys are not. I think I did a good enough job if you were to ask me presenting this topic. And I think you guys understand the topic. The problem is just the computational skills. They must be improved. So come guys, I'm waiting on you because I'm gonna generate something here. I'm hoping that's gonna work now. Um All right, miss. So what I'm saying to you now in part B of the question, I'm saying to you that I'm saying to you that um, the actual integral is 7/3 units squared. And I want you to calculate the error now. Go ahead, look back at what was done and see if you can calculate the error in the calculation for me. And come back and talk about it. 3 minutes. Those of you who are still working, you need to finish off the question. And I don't like how some of you.
Is that answer correct?
Which one? Your last one?
Yes, sir.
All right, I'm responding to you. I don't like how some of you coming to. I don't like the participation from some of you in my class. For sure, I can guarantee that I'll hear some students participating, and it's the same ones over and over. If I don't call upon you, you don't try to participate. This is calculus 2. There's no spoon feeding here. And I know exactly what is happening. Some of you are not following, and you want to stay in the shadow. I will help you stay in the shadow. You need to speak up, make your mistakes in class, so I can know where it is that you are not understanding. So come on, talk to teacher. All right. Yeah, go ahead and do the calculation, the error calculation for me, please, and thanks. You know, let me ask: is there anyone struggling to do the first part of the question? And if so, where exactly are you struggling?
Uh,
Finish your thought, man, Demoy. Talk to me. Let me hear what it
all right.
is.
All right. So, sir, is the beginning part where you're supposed to get the A and the B over the N. A take away
Mhm.
the B over the N. Sir, I get an answer, sir, and then when I put it in the calculator next to the other number, I'm getting like up to five things, and I feel like that's wrong. So I'm here just keep on doing the same thing over and over in the calculator.
Mhm.
So I feel like I keep getting the wrong answer.
You know, one of the things that I don't know if I'm gonna do that. All right. Mm. Oh, all right. I'm gonna think about something and then come back to you. Um, all right. I'm thinking about something to come back to you. It's something the more that I know affect a few students. There are a few things that I can do to correct it. If I were in a face-to-face session now, I would say put away all books. And I say put your calculator in hand. And I would have gone to the board and written up one or two things on the board and asked you to follow the algorithm to to strengthen your calculator usage. And if we go put on TikTok, and start learning for using the calculator. All right, let's go. I sense that there are some students struggling, and it's not a nice thing to struggle. It's even more so not a nice thing to struggle and then struggle alone. So let us attempt to do the solution. So I'm asked to integrate x squared minus 4 dx. Upper limit 3, lower limit is 2.
Excuse me, sir. No, can you
Uh,
check the chat for the second part, please?
All right, I'm seeing it. I soon tell you. I see it. And then now, v of x is going to be b minus a all over 2. It's going to be 3 minus 2. Did you get a half right there?
So it's not
So I never four.
it's number four.
Very
So
good.
never four.
Very good. Tell me where the 2 comes in play now.
2 comes in play when
V
you
of x over 2.
yeah VFX over 2.
Okay,
Yeah.
good. All right, excellent. I'm happy that you see it. Now, um, I'm happy that you see that. So it's going to be 4 because it says with 4 trapezoids. So it's going to be equals to a quarter. So please don't get mixed up with that 2. That 2 there is going to always be there. And it's Vx over 2. So it's going to be that. So my ordinals are, I must start here. And I must end here. I have to start and I have to end. My start, don't ask me, sir, where we start? At the lower limit. Sir, where we end? At the upper limit. All right? So if I go by 2, so I see them with 2, then 2 1/4, then 2 1/2, then 2 3/4, and then 3. Talk through.
Oh yes, sir.
All right. I guess you would have written it in this form. Comma, 2, 2, 9 over 4.
9 over 4, 5 over 2, and then 11 over 4, and then 3.
Good. Same difference. Good job. Full marks. And then now we are going to have our function. We're going to say f of x recall f of x is equals to x squared minus 4. So therefore now f of 2. Why am I feeling that the place is shaking? Honestly. 2 squared minus 4. That's 0, don't?
Yes, sir.
9/4 squared minus 4. 9/4 squared minus 4 is going to be 81/16 minus 4 is equals to
1.06.
1.06. You can't give me that. After 2 decimal places, so you have to work in 3 or more. If I ask for 2 decimal places, it can't start working 2. And maybe that's why some of your answers are off.
Oh,
You hear the question that was asked at the top of the question? The question that was asked at the top was, how many decimal places, sir? And I said to you, 2. And the mere fact that you know that it's 2 decimal places, it can't work in 2. You have to work in 3 or 4. So 1.6, 1.0 what?
1.0625.
So that's 1.063.
Yes, sir.
All right. And then now, f of 5/4, 5/2 is equal to 5/2 all squared minus 4. That's 25/4 minus 4. 16 minus 25 is 9. That's 9/4. That's 2.25.
yes, sir. That means it.
2.250. Let me know if I'm doing this calculation off my head here, guys. So help me out. 5/2 and 11/4. So f of 11/4 is going to be 11/4 all squared minus 4. That's 121/16 minus 4. That's 64. 64 minus that, minus 121. That's 36. 46, 56, 57/16. Somehow that doesn't wrong. And I got my calculator. 121/16 minus 4. Yeah, 57/16.
Yeah.
3.563.
Sir, would it throw off the calculation if I use like the whole value?
You're even closer to the approximation if you were to do that.
Okay.
So you notice that's exactly what it is that I'm doing here now. I'm not putting any decimal in my stuff. So you're even closer. So f of 3 now is going to be equal to 3 squared minus 4. 3 squared is 9 minus 4. That's equals to 5. So the integral of x squared minus 4 dx is going to be equals to a quarter divided by 2 times 0 plus 2 times Should I follow up on a door? Or should I just do it my way? All right, I'm gonna do it. I'm gonna do it whole. I'm gonna do it whole. It's 1/16. Um, a quarter divided by 2 is 1/8.
Yes, sir.
Yes, sir.
34/16 plus 2 9s are 18/4. 114/16 plus 5. 1/8. So in this case, Kahim, I'm taking into consideration let's use my fractional form. I'm not using any decimal until I get to the last piece. So that's going to be 0 plus 34/16. So I'm putting 34/16 in the calculator. And then I'm 18/4 plus 114/16 plus 5. I get 75/4. 75/4. And then I'm going to end up with 75/32, which is going to be 2.34.
Sir.
Yes, Papa.
Yes, sir. If you get a question like this on the exam and it says to 2 decimal place. So if we record the fraction form until we reach the last part and that's where we record the decimal places, we wouldn't get marked on for that.
That's how I want you to do it, just like what I'm doing it here. That's exactly what I want you to do. I don't want you to go here. I only facilitated you because I know that you guys did the calculation in decimal form. So I only facilitated you here to make it to see if you got the same answers I did. Right? This will be fine, and this will be fine. It's just those numbers that I'm a little concerned about because you're rounding those numbers there. So in a round those numbers, well, the 2.25 is okay because this was a terminating decimal. So let me uncircle this. That's a terminating decimal. So that will be fine because the actual answer is 2.25 flat. So that's terminating. But the other two values now will distort the values that we're going to be getting. So my recommendation is it will give an exponential function to work with. The exponential function not being able to get it in fractional form. So from the get-go, you have to do it in decimal for the exponential function. But functions such as these, and the logarithmic function may also give you, you may also get it straight decimal form. But once it is that you can get it in fractional form, just work with it, man. Work with it.
All right, sir.
Yeah. I'm very hopeful that you all can pull through with this course. And let me just pause and just use maybe about 5 minutes just to motivate some of you who don't know how to dream and dream big. Last Thursday was our graduation, and as one of the deans, I didn't have a choice. I just had to be there. And what was what was very fulfilling for me is that when I walked around the back to be robed, I heard students saying, "Hi, Mr. Shand, this is such and such." And I was like, "Oh, that's you?" I would have taught those students one full academic year, semester one, calculus one, semester two, calculus two, and didn't have an idea what those students looked like. "Sir, is John Brown this, you know?" I was like, "John Brown?" It's like, oh my goodness. Because to my mind, I'm talking to you, John Brown looked like one big fat person in my mind. But when it comes John Brown is just one small person. There was one student that I knew really out of the group per se. And she called me like not one. And she called to me and I greeted her pretty well. And then I guess it's because she said, "Hey, Mr. Shanda," other student. And I said, "Oh, Mr. Shanda, what's the point?" It was very gratifying to know that you are the same set of students who are now sitting in the position that they were in their year three. And they did well and were able to graduate. Calculus 1 and Calculus 2 never kept them back. They were able to graduate. And I'm saying to myself, so I will stop the money from finish all them Calculus 2 and graduate too. Beautiful feeling. And I sat back and I looked across the stage when I see people walking, and some students I know their story. Them struggle, them do one course 2 and 3 times just to pass it, but yet see them still pass it. And them walking across the stage. It was a beautiful feeling. Beautiful feeling. And then to top it off, one of my students who sat in my class was one of the valedictorians. Last year, the valedictorian was a computing student again. And the person who gave the vote of thanks was a computing student. Right? So has been a very fulfilling feeling. And to know that my evening students are copying the top performing students within the institution. So the evening students are outperforming the day students by far. The highest GPA is a nursing student. Yes, that person goes to the day school. But the second highest were two evening students. Two evening students. It was a really good feeling. Students, let me tell you something, man. I only put time there to take off my glasses because the eye water drop out. Because I know in a lot of students don't recognize what lecturers put into this. I can declare it. I am not well. Really and truly, I should be saying to you guys, yo, take the evening year because teacher not well. I'm gonna say no, I can't do that because it's gonna come and haunt me at the tail end. I have to go through. And just like what teacher can push through, who want you to push through too? Don't tell me about, sir, the school fee don't pay. Don't tell me about, sir, I having problems at home. Don't tell me about, sir, I having problems at work. I know those problems are real, just like how I am not well, and that is very real. And I'm pushing through. I want to push through. Push through, man. The people that at work are getting problem, push through and finish the degree. And I'm going to say, blow out, despite me I give the person trouble, them still finish them degree. You're having problems at home, despite the home challenges. I do that. Despite not being able to pay the school fee on time and support, I still finish. Trust me. You can write a story thereafter and you can motivate. Finally, one of the things that touched me deep, deep, deep down to the core, deep, when the students were asked if they are first generation graduates within their families. And I saw, but I would say about half of the graduating class stand up. It, shivers went through my body. What that means is they are the first one to enter tertiary, and in the case, the first one to complete a bachelor's at tertiary level education in their family. And the truth of the matter is, students, and some of you be able to identify with me, some of these parents are taxi operators, domestic helpers, office attendants, and they do menial jobs. Yes, I know that you have one or two parents out there who are are well off and can assist you because they are program and support and so on. But I'm also seeing that the parent profile is not a champion or immaculate. The parent profile represents majority of Jamaicans. And if you can come and do something like this to help your family, do it. And when you finish the degree, don't twirl the nose at the rest of the family members. Ensure say your little sibling them get one education. Not to me say, boy, sorry for them a tough for you, make them get some even a skill. And this is when we pay out of your pocket. You understand? And not to me say, boy, my people them not care about me. No. Pay it forward. Pay it forward. All right. So when I don't come to my class and come sit down and go like when you can open the mouth and talk. All right. Come to my class and participate. Do the stuff so we can sit down and watch across the stage too. All right. So 2.34 units. Unit squared would be the approximate integral of the function. Now, the question asked me now to calculate the error. Question asked me to calculate the error. Anybody remember the error formula?
Yes, sir. K bracket B take away A bracket cube over 12 n squared.
K take away what?
No, no, not K take away, sir. K bracket B take away A
Okay.
cube.
And K is going to be less than or equal to the second derivative of f of x, don't it?
Yes,
Sir,
sir.
it's not squared.
Say it again? Oh, no, it's not squared. You know, cube. Is it
Yeah,
cube?
cube, sir. Yeah, cube.
It's not me. It's a marker. It's a color marker. It's on the wrong side of North Street, so that's why.
Sir, yeah, Georgia.
The wrong side of North
Sir,
Street.
my
That's
son at night, you know, him not get it.
cool. Easy, 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 easy. All right. What is the function again? F of x is equals to what again? X
X squared
x
minus 4.
x squared minus 4. So f dash of x is going to be equals to 2x, don't it?
Yes, sir.
Yes.
And f double dash of x is going to be equals to 2. So we know what our k is, don't?
Yes, sir.
Yes,
2.
sir.
3 minus 2 all cube all over 12. N was 4. 4 squared. This is how easy this is. So 2, 1 cube over 12 times 16, don't it? That goes 8. Boy. 1, 2, 8, 16. 8, 1, 8. 1 over 96, don't it?
Yes, sir.
All right. Very good, Lakana. I see you have that verbatim as 1 over 96. I see you put the 0.01, 0.0. All right. All right. So, but oh, what did I ask you? Let me see who I worded the question. I asked you to calculate the error. Okay. All right. So that would be the error. 1 over 96. Now, as a percentage, it would be 1 over 96 times 100%. Remember, you have to put the percent sign here. So 1 divided by 96 times 100%. Where you get rid of that?
Sir, when do that we get 25 divided by 24? And when we divide that, we get 1.04%.
Good job. 1.04%. All right. So very good, Alvin. You also got that. Very good, Rayton. You also got that at the 1.04. Carno, you have to go try. You got the 1/96, but you have to go try the percentage something again and come back to me, Carno. And come back to me pretty soon because I
Yes,
want to
sir.
see.
Me never times it by 100, sir.
Okay.
That's fine.
All right. So yeah, that's it. Very good, guys. Very good. Very encouraged. There are some of you in the class, however, that are not following to the max. One other thing. Is if I make the calculus to run with you, you can't dark. If I make the calculus to run with you can't dark because guess what? This finish now, you know. See me just seal the trapezoidal. Just seal it a while ago. So we can ask a question now. But in the class, are we in a question? That's seal, you know. Seal, put up, done.
Sir,
Yo,
I'm not sure. Well, I don't think I was in the class when this was done, so this is the first time I'm actually seeing this. How do you put the 1/96 times 100 in the calculator?
1 divided by 96 times 100. It simply means, Kahim, that you have not been watching the videos then because the videos have been, are there on this introduction. All right. Oh dear. I'm moving on to something else. But I'm trying to see how best I can introduce the topic.
Sorry, can you scroll up a little bit, please?
There is good.
No, sorry. Go back down. I want to look at the second part. Okay, sorry, thanks.
All right. I was going to show you a video.
So, sir, K is the differential of the formula when it is a whole number.
Ask it again.
So, K is differential of the formula once it's a whole number.
The
So, once
second
you
derivative.
derivative. Oh, sorry, derivative.
Mm-hmm.
Tau is the second derivative.
Yes, I.
Oh, okay, sir.
Mm-hmm.
Thanks.
Cool. All right, let us have a conversation. I am moving into a new area. Let us have a conversation. Now, I was I think I was cheated out of this IT era when I was going to school. Ouch. Because the first time I used a computer in school for educational purposes was when I was in my penultimate year at the university. Penultimate year at university. When I was required to digitize a map of the central inlet of Jamaica. And I remember the university was given a grant and we got, could be about 10 computers. It was a small area, about 10 computers. Because you're studying computing, you will know about floppy disk. You know, the big square looking side or something that if you bend it, you know, so you know, have no more use for it. Yeah, man. That really have to use to store information. And I had to use we call it now, the composition hardcover books to put my disc in between the book leaf and use a hardcover to protect it. Flash drives weren't around at the time. People never used to walk with lanyards around the time, run them neck, because it just never did about. Just never did about. Emailing system never even come up them time there. And the long and short is that I was doing pretty well at my thesis work and, you know, did exceptionally well there. But when it came time now for me to go and print my thesis, the information could not be found on the disk. Fortunately, if you know me well, once I reach certain place, you know, I'm gonna print my hard copy because it's only hard copies I knew about. So, you know, to this very day, there are some things that I have in hard copy. There are some things, yes, I keep in soft copy, but there are some things that must be kept in hard copy. And I remember my thesis was due the Friday. And when I went to print, nothing could be found. And, you know, only talk about Excel wicked. my supervisor tried opening it and it couldn't be opened. And he knew of the situation. And they gave me up until the Monday to submit the document. Now, of course, I proudly will tell you that I didn't own one of those computers at my yard. So I had to go somewhere to get it done up. And I presented, you know, the rush retyping of the stuff. And people, I used to joke and type because everything, as I said, was new. And I did what it is that I was supposed to do, you know. My friends who used to do typewriting and so forth, I called them around and everybody had a section of the stuff doing for me while I was doing the stuff and, you know, presented my thesis, support and so on. And I was still penalized. I was penalized because it was supposed to go in on a Friday and I submitted it on the Monday. Even though the university knew about it, they penalized me. And guess what? You know the hottest part of it? It was a double course. It was like 8 credit courses, like what you would call a capstone project, right? That summarizes everything that you have done. It hurt me because they penalized me. So I got one of the lowest passes because you can't submit your work late and still get an A. You know, like how some of them decide that, oh, sir, I couldn't upload the stuff and then on still, sir, still marked and on still get an A. It doesn't operate like that at the university. All right. So if you're supposed to get an A, you're going down to a B or a C plus. So I thought it was unfair, and I went to the lecturer and I said, boy, sir, I think this was kind of harsh. You knew of my challenge support and so on. And one straight answer, and then him just step, university policy. I'm just step, no compassion. No compassion. All right? Anyhow.
Thank God you're compassionate, sir.
Yeah, man, trust me. If I tell you some of the things that I go through at university, I could never be a teacher and replicate those things to my students. So now, fast forward to today day, when I don't know how you guys view it, but one of the things that I love to do, incidentally, there was another plane crash today, well, not a plane crash. Yeah, plane crash, get crashed. Plane turn over upon the runway. Anybody see that?
No, sir.
Oh, sir.
Yes, sir.
Plane-
See it
Never
earlier.
yet, sir.
See it again?
Again? One explain crash again?
Yes,
It
When?
was landed on its slide and turnover.
yeah, slide on turn over today. It's last night? You said last night,
Not
Kenny?
sure not sure the exact date, you know, sir, but it was
Oh,
between this morning and early this morning.
yeah, and
Not sure the time.
it's today it happened because when I checked when I fact checked it, the information was coming in 35 minutes at the time when I was fact checking it. Yeah, so yeah, man, just injuries, no deaths, praise the Lord, just injuries. But I went to a conference and I hear them talking about 3D printing. I was like, 3D printing? What the heck is 3D printing? And then sometimes I used to go, when I used to love traveling. I mean, all this Bolívar plane crash since 2025. Said, we're not going to go there. I used to go to these stores, local, overseas, wherever, and they see them selling, for example, fruit bowls. Let us use Azan. And he decides, boy, you're the plan. My soup bowl kind of a little bit, and when I cook soup on Saturday daytime, I get a little bit of soup. You're the plan. I go buy some real man soup bowl. And you go there and you see them have sets of soup bowls and all of them are the same size. And you wonder how they make the soup bowl, especially like the wooden ones, how they make it and get it the same size. Well, let me tell you, the way technology has moved now is that they can just go ahead and calculate and input a volume into the computer to say, yo, I want it to be this wide and this deep, and give it some formulation. So it may say to you that it is y is equals to 2x squared plus 8x minus 2 between 0 and 3. And the computer reads that. And you go ahead and you put on your piece of wood on the spinner, and automatically carves out that soup bowl with a particular volume. So therefore, the operators can carve as many of those containers with the exact volume. Back then in the day, you get soup bowl and you have different volumes because the man just a carve out, and when him decides, say, oh, I eat this, that is it. Right? So matter of fact, they used to drink out of calabash calabash mugs they used to have. And not all calabash were the same size. So you have some big and some small, just like a coconut. They used to use a coconut to eat out of, right? They have some big coconut, so you can get the ox. You have small coconut. And then now, going back to the 3D printing, houses are being built now in today's world using 3D. And guess what? They are cheaper. They are more they are fireproof, heat resistant, so you're using less energy, fuel efficient. So there are so many pluses to these 3D printing. Where does all of this come from? All of this that we're talking about here come from volume of or rotation. All of these come from our volume of rotation. And it says here, integration can be used to find the area of a region bounded by a curve whose equation you know. So just like how when you go to like all Toyota International, and the big man calling to the office and say, yo, we want to make this amount of money as profit. You know, we'll have to say, all right, bossy, we have to manufacture. Toyota Camrys are our best sellers. So because it's our best sellers, we have to go start there and make more of those. The Mark X, them boy, the Caribbean people, them love the Mark X, you know, so we can manufacture quite a bit of those and ship those to the Caribbean, right? And it's so coming with something, and the man say, blow, you know, say, anyhow, we realize all of these sales, you know, we can get a good change in our pocket because you get gratuity out of it. But you must know the formula. The equation must be known. So if we want to find the error under the curve, for example, y equals 2x squared plus 8x minus 2, between the limits 0 and 3, for example, we are going to integrate the function. We're integrating the function between the limits. And then we're going to imagine that a curve is rotated about the x-axis so that the solid is formed. So that the solid is formed. And then the volume of the shape that is formed can be found using the formula, and that's the formula, the volume formula. The integral of the limit, upper limit, lower limit, pi y squared dx. Now, I want you to understand this. A man meet into an accident, and you know, mash up him cylinder somewhere in the car, gas tank, or the reservoir for in screen wash, whatever the situation is. Do you believe that a mechanic can engineer a substitute and put inside here? A muffler
Yes,
is another
sir.
example. Yeah,
Of
man,
course,
easy,
sir.
easy 1, 2, 3 that. Easy 1, 2, 3.
Simple thing
Right?
that.
Simple something. Volume of rotation. So one day I went to my mechanic and I'm saying to myself, well, my mechanic is really an engineer by trade. Go good school and get an engineering degree. And I was waiting for my car to be serviced, and I stood up and looked to see where he was calculating the volume of rotation of something, because he wanted to go and fabricate something. So when he must send something to be fabricated, now him tell them to work on them, say, yo, go on the man, you see, I'm wanting to fabricate it. I mean, it's supposed to be this, it's supposed to be that, it's supposed to be this. Make sure you give him this. Now, the man always reading this up, better understand him at all, because if it not fabricate properly, it means say it will be too big and it now go able to fit in the car. You understand? If it's too small, it will create problems. They want it at a particular size. And I was checking the calculation, and trust me, I was proud of the man. Mark you, he's an engineer. Calculation correct to the T. All right? So the first thing that I'm going to point out to you is that I am doing a rotation about my x-axis. And I want to come close to the screen to look at this. I'm doing a rotation about my x-axis. Now I can also do a rotation about my y-axis. The formulation is going to be different. So if I'm doing a rotation about my x-axis, it means that I'm integrating with respect to x. See here, so dx. That means my function must be in y. I can't be in dx and my function is in x. Can you agree with that?
Yes, sir.
Yes, sir.
Go again, sir.
All right. So I'm rotating. All right. We did something similar to that, you know. When I'm finding the y-intercept, what must happen?
Substitute 0 into the formula.
X equals 0.
X equals 0. Could I put y equals 0?
No, sir.
No, sir.
No,
Sir.
because I'm finding the y-intercept. Says the other one will be equals to 0. Similar something right here. So I'm rotating about the x-axis. Let me spotlight. I'm rotating about the x-axis. I'm rotating about the x-axis. It's a rotation about the x-axis. That means that my function is going to be, I'm going to be integrating with respect to x. I'm rotating about the x-axis. I am going to work in x. It means that my function is going to be y squared. So if I'm integrating with respect to x, because I'm rotating about the x-axis, it means that my function must be in y, can't be in x. I can't have x squared and then dx. If it is x squared, it has to be dy. And if it's dy, it means that I'm rotating about the y-axis. And guess what? If I rotate about the x-axis, I will not get the same shape as if I were rotating about the y-axis. Two different things. If I'm rotating about the y-axis, even if I have the same formula, it's going to be a different shape that I'm going to be getting. Does that make sense?
So far, I'm moving to the practical aspect and I get it better.
All right. You know, I had
Same,
a
sir.
lovely. Say it again.
I'm saying the same, sir.
Okay. I had a lovely student who one day I was teaching this and he just went on his computer and did something. And for the rest of the semester, he was able to do it for me. But let me just try and show you something here. Don't do this to me now. If I'm rotating this shape about my y-axis for argument's sake, what shape you think is going to be formed? This is what I'm rotating about the y-axis. What shape you think is going to be formed?
N.
No, man. You don't think I will get... Sorry. Something like that. Look at it. I'm spinning this. I'm spinning this. And when I spin it, it don't look like it can sit down in yourself and that something can hold inside yourself, which is inside yourself. This here don't look like what I just did right here, sir.
Oh, yes, sir. Let me see it. Oh, if that's been clockwise or anti-clockwise.
Very good. Very good.
Yes,
Very good.
I mean, they look funny the opposite way.
Right.
Like that round, so.
One of the things that I find is we don't do lots of spatial things in this part of the region. I'm able to see some stuff because I was introduced to technical drawing. I don't know a lot of you did technical drawing, right? And you had to look at different views and you had to be picturing and imagining things, what things can look like. Even the man can't see it, you're a step or two ahead of the person because you can see what it looks like. But yeah, I won't ask you to sketch necessarily what the figure is going to be, but it's just for you to have an idea that yes, you are going to be able to calculate the volume because the volume is going to be how much can hold into something. See here, how much soup can hold into this bowl? How much soup can hold into that bowl? Just coming from this something here. So this curve that you're doing is defined by a function in f of x because this is a parabola. Just like this. That's also a parabola. Minimum turning point. See, look like for you. one of the things I remember going to a math conference and I was very intrigued by it. And this is why I tell you that I have a preference for Casio calculators because we're in St. Louis, Missouri, and they took us out downtown. There's a St. Louis Arc. Let me see if I can bring this thing to life. Then LOUIS ARC. Image. Let me go to image and then kind of pick up one of them. Let me know if you see the screen.
Yes, sir.
Yes, sir.
All right. So this is in St. Louis, Missouri. And this is a famous arc, downtown St. Louis. All right. Now, that was my first time going to St. Louis. Now, imagine when I go down there and I go downtown. And when I went downtown, it was maybe sometime looking like this, or maybe this one, night was just coming and it lit up. Could be this one. Night was just coming, lit up and looked really, really, really nice. And I was like, then let me ask a question. How many people would I really sit down and go build something look like so? The people have no sense in them have no time for weird, they have time for waste. And I stood at a distance and I started judging. Them said, look, but don't judge. You know that inside of here, well, you don't know, but I'm telling you, inside of here, you have restaurants, you have different types of eatery, you have different things that people can go tour and so forth and so on. And I was like, oh my goodness, it looked like this from a distance. We can actually go inside and tour the whole of St. Louis. Now, I would have taught you something in last semester. What does this shape look like? What does this remind you of?
Sir, I forgot the name. That thing we do,
The minimum also. The minimum.
Would
when
this
you
be a
find
minimum?
the intercept,
Maximum.
This would have been a
maximum.
maximum stationary point, and this would have been a maximum curve. All right?
Yes, sir.
Good. So that would be a maximum curve.
Focal
Now, as I said, why I love the castle, and I do have one, but I can't find it. So I can't even say, boy, make a meet one day and I can show you what is done, right? But let me tell you what the guys did, and show off for me with the, oh Lord, I lost what I was looking at with the calculator. What they did was to go out downtown one night, took us out, they said that, okay, you guys are not, from the area, don't worry about it. We are going to have dinner at 7 o'clock. Let us meet right here. So you're a good little teacher, go back to the hotel and get ready and jump on when I'm supposed to jump on the bus, and took me downtown, and, we met up, say, hey, we have on our badges so people know that we are here for a conference and thing. Very nice people there. Went for dinner, and just before they said, let us go, and we're going to take a photograph of the stuff. Now think about it. The man them took a photograph using a cellular phone, took a photograph, and they saved the photograph on the computer, and then they superimposed the photograph of this arc into the Casio calculator. And the calculator was able to give you the equation that was defined by this negative x squared, with no say it will be negative x squared because it's an n. Had it been a u, it would be positive x squared. Talk truth.
True, sir.
Yeah, man. So it gave the formulation. I don't know what it is. I can't remember what it is now. It could be negative 3x squared, but I know that there was a negative x squared there, so forth and so on. And it gave the formulation. And I sat down and I was like, whoa, this is where the technology is. And it was able to do the calculation. So we were able to find the turning point. We were able to find the maximum point right up here. So I don't know if you've seen the screen. Are you seeing the screen?
Yes, sir.
Right up here, so is where we're going to call it turning point. Because why? We'll go up, we'll go up, we'll go up, we'll go up, we'll go up until we don't have no more up to go. But if we go one step, it's down we're going. This is going to be our stationary point. This is going to be our turning point. This is going to be our critical point. And the calculator was able to calculate all of those points, just like Sir Shan taught you. All right? So this is mathematics in the real world. It is mathematics in the real world. And when I finish teaching, you know, I want to go look on the Missouri app because this is not a make-up story. Spent my good money to go there so I can come and teach and show you guys what it is. The calculator was able to superimpose to do all of that. All right? So let me
sponsorship, sir.
say it again.
Sponsorship. You mean sponsorship?
No, sir. Not always, sir. You have to spend the money sometimes, you know. No man, I have to spend the money sometimes, man. It's an expensive thing though, to go. But you see, I go to these math conferences because I really want to learn the new technologies to come back and to show you guys what it is. Because sometimes we're learning in a vacuum, you know. I'm a math teacher here in Jamaica, and some of the things where when I go, Kenneth, to some of these conferences and I am tertiary, and I was like, oh, but I can't go to a grade 6 to grade 8 session because I don't teach high school. I teach college. I want to go to the big school, something. And people said, come on, we don't have anybody here. Come on. And I went into one of those sessions and I sat down and I was lost. I was lost because those students are using graphing calculators from in grade 6 to 8 session. You know, they're using graphing calculator, and they are doing some stuff. They are doing stuff that I don't know how to do. Because you'd have gone through school, you may do a little one something here, saying, so okay, fine, it happens like that, boom, you don't do it again. But this is what they are doing. And I will turn the person and say that, this is what you do. Oh yeah, this is coming or something. I say, all right, me soon come. I have to take with myself. Take with myself good time too. Because we don't have the technology here in Jamaica to do it. When you go abroad to school, somebody in the class is sitting around their personal computer, or they carry their own tablets. Them called BYOD, bring your own device, right? And guess what? The next conference I went, I said, okay, fine, me buy one netbook. Well, my wife bought me a netbook, and I said, oh, we got a conference and we back up my netbook, and we start recording and everything, and everybody around me now is taking out their tablet, their Mac. I mean, I have to slide my MacBook back, my netbook back into my bag because that was maybe 10 years before I got mine. So everybody's now using Mac, right? And I Pro 11, 13 inch, 11.9, 13 inch. So it's like them walking with a desktop in their hand. Powerful stuff. And they're doing things on that MacBook that you know, it's just where the technology is. It is where the technology is. And I really hope that I had the technology to say, guys, come, let us go into the lab so we can use some of these technologies and show you how it is done. All right. So this is what is going to happen now. I'm going to do this example, this very question, y equals 2x squared plus 8x minus 2, right here. So this example that I gave you up here, teachers going to do the calculation now. All right. But there are two things that I want to point out to you. Pointed them out already, but I'm going to point it again because very critical, very important piece of information for the calculation. Watch me, come close, watch me. When I'm doing this calculation, I must know where it is that I'm rotating. See it here? The graph of y squared between x equals 0 and that is rotated completely about the x-axis. I must know this information before I start my calculation. If it is rotated about the x-axis, it simply means that I'm going to have the integral pi y squared dx. The integral of pi y squared dx. If it is rotated about the y-axis, I'm going to have pi x squared dy. It's very important for you to know the formulation before you start doing the calculation. Pi is very important. Talking about a complete revolution. Sometimes it don't have to be a complete revolution. This one here is rotated completely. A complete revolution equals what? How many degrees?
360.
360. I can give you a question and say that it is rotated 180. It means that it's just a half a rotation. Or I can say that it rotates 270. It's a 3/4 of a rotation. Or I can say to you that it rotates 90, which is a quarter of a rotation. Real talk. Real talk. How could I forget this other example? When you're working into the manufacturing industry, you see the water and the can water and the Pepsi and them something there, the little plastic bottle they might drink out of, the one that causing a nuisance to the pollution in other harbors. Those are, look at your index finger. All of you look at your index finger for me. Your index finger is between your thumb and your middle finger. That's what we call index. The bottles that come are like that. And then now these manufacturing industries, Wysinco, Lasco, Grace, have something that they call a blower. And these little bottles, like a vial bottle, is placed in the blower, and the blower blows it up to either the 330 milliliters they want, or the 560 milliliters for the Pepsi, or the 600 milliliters, or it blows up into the 2 liter. Yeah, man. So you determine the sort of blow up, the sort of volume that you want, and then it blows up to that volume. Am I making sense there?
I mean, yes, sir.
Okay.
Yes, sir.
So the complete revolution is going to be 360 degrees. All right. When I'm finished with this class, you need to go on YouTube in order to concretize what it is that I'm doing and look at the Missouri arc, look to see how it is that these bottles are blown up and what it is that they do in order to get the volume in, so forth and so on. All right, let's go. So it says it's going to be y squared. No, all that they gave me is y. So therefore, I now need to find y squared. If they give me y equals all of this, how do I find y squared?
Sir, y times y.
So therefore, you're going to multiply 2x squared plus 8x minus 2 by itself, right?
Yes, sir.
Okay, see here, sir. No, when I taught you integration in calculus 1, this pi is a constant, so I can take it out and put it in front. Anybody remember that? It's a constant, so I can remove it and put it at the front. See here, this is what I did right here. I'm putting a pi at the front. Because what's the value of pi? Anybody knows?
Sir, 3.14.
0.14.
Or 22 over what, 7?
Okay, so all of you are wrong. It is approximately 22 over 7 and approximately 3.14 or 3.142, right? Pi is not an exact value, right? It's an approximated value. But yes, we approximated to 22 over 7, Andrew. Yes, you're correct in that regard. And as a decimal, it is approximated as 3.14, but it's an approximation. It's not a exact value, right? Okay. So now you recognize it says y squared. So I'm going to have my y and I'm squaring it. So look at what is going to happen. This is a graph of 2x squared plus 8x minus 2. It is rotated about the x-axis as opposed to this one that was rotated about the y-axis. This one is rotated about the x-axis. So look at what is happening. See the graph here, no? The graph is right here. So the graph comes here. That's the graph. When I rotate it about the x-axis and I'm going around in a circle about the x-axis, here so is going to give me this sort of oval. and this is the shape that is formed. Rotated about the x-axis, now I have something looking like a cone. Talk to me.
Yes, sir.
Yes, sir.
Mm. And then now we can calculate the volume. So we now need to expand 2x squared plus 8x minus 2 by 2x squared plus 8x minus 2. And look at all that we're going to get here. Watch me. 2x squared times 2x squared is 4x to the fourth. I color-coded it for you so that you can see what is happening. This same 2x squared times 8x is going to give me 16x cubed. 16x cubed. I have one more, so I have to go back to the same 2x squared. So 2x squared times negative 2 is going to be negative 4x squared. See here? Negative 4x squared. There's nothing more in the second bracket. So I'm going to finish with this 2x squared and move on to the 8x. So 8x times 2x squared is 16x cubed. See here? 8x times 8x is 64x squared. See it right here. And one more, 8x times negative 2 is negative 16x, right here. There are no more terms in the second bracket. So I'm going to go to the last term here. Negative 2 times positive 2x squared is a negative 4x squared. As I say, I color coding it so you can see exactly where we are at. And negative 2 times 8x is going to be negative 16x. See it right here? Negative 16x. And a negative 2 times a negative 2 is going to be a positive 4. All I'm going to do right there is with my terms. When I look inside here, I recognize I have only 1x to the fourth, which is 4x to the fourth. I write it back. When I look inside here, I recognize that I have 2x cubed, 16x cubed and 16x cubed. 16 and 16 is 32. So that becomes 32x cubed. I'm looking at my x to the fourth, my x squared. 1x squared here, plus another x squared is going to be 60x squared, 60x squared, and then I have another x squared. I'm going to have 56x squared. So how you get that? This is a negative 4x squared plus a 64x squared. That's going to be a positive 60x squared. And then a minus 4x squared from that is going to be positive 56x squared. See it right here, so? And then I'm moving to my x. Did x to the fourth, x to that, moving to my x now. Negative 16x minus 16x is a negative 32x. See it right here? And the lone sum whole number 4 goes back here. So this is me expanding my y squared. Simplifying my y squared. I have something to the fourth, to the third, to the second, to the first, to the 0. Then I'm going to be integrating. When I integrate, I add 1 to the power. Of course, you can back your upper limit and lower limit and the pi. So all of these are constant coming down. You're just trying to work out the inside of here. So now that you've removed your parentheses inside here, you're going to go ahead now and do your integration. Remembering that when we're integrating, we're adding 1 to the power and then we're dividing by the new power. So this is x to the fourth, we'll add 1 to the power, so it can become x to the fifth divided by 5. So it's 4x to the fifth divided by 5. But I added 1 to the power divided by the new power, 32x to the fourth over 4. See here? 32x to the fourth over 4. Adding 1 to the power divided by the new power, 56x cubed over 3. 56x cubed over 3. Add 1 to the power divided by the new power, negative 32x squared over 2. See here? Negative 32x squared over 2. This one 4. Adding 1 to the power divided by the new power. The power here is going to be x to the 0, so it's going to be x to the first. See here? X to the first. And divided by 1 is still x to the first. So I'm going to have my 4x. All right? So this is my integral. So now that I've integrated it, you notice I remove my integration sign and place it now into square brackets. And I'm still putting my upper limit to be 3, my lower limit to be 0. I am going to stop right there and ask, are you understanding what it is that I've done so far?
Yes, sir.
Okay.
Yes, sir.
So just remember, you're integrating, you're finding the volume of rotation about the x-axis. That means you're supposed to have y squared dx. So remember, if the function is not given in terms of y, you have to make y the subject and then you square that something. Be careful when you're squaring that you're squaring correctly, because if you don't square correctly, it means that the function that you're working with is not going to give you it's going to be the incorrect function. All right. So When I square it, then I'm going to be putting my like term, grouping my like terms together to get a nice product looking like this. Then I'm going to integrate, remove my integration sign, put my upper limit, my lower limit. Recall, it's always going to be the upper limit minus the lower limit. Now look how this works out nicely. You notice my pi is constant here, 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 and here. It must be constant. Now it's upper limit minus the lower limit. Look at what teacher doing. I'm substituting my 3 into every term inside here, and then minus it from the substitution of 0 for every term inside here. So this is 4 to the third to the 4 times 3x. What is this? 4 times 3 to the 5th, because anywhere in the function I see x, I'm substituting my upper limit. So all of these going to be 32 x to the 4th over that. But so I don't say 32. You know what teacher did? Say 4 into 32 goes 8 times. I just call this 8. And sir also said that 2 into 32 goes 16 times. That's why sir only have 16 right here. All right. So I'm substituting my 3 into the function, into this function here. And then I'm also going to be minus by the substitution of this of the 0. But if you recognize all of this, this will go to 0 if one's 0 in here, because 0 over 5 is 0. Similarly, I just put minus 0 because there is no term that is going to give me anything other than 0. You have to be careful that when you're doing a question like that, because I don't want to fall into a trap, because sometimes there is a trap there to catch you. 3 to the 5th is enough, times 4 is going to give me 972 over 5. 3 to the 4th, 3 3 is 9, 9, 81, 81 times 8 is going to be 648. 3 cubed is plenty, times 56 is 1512, divided by 3, and 3 squares is 9, and 9 times 16 is going to be 144, and 4 times 3 is 12. And I'm going to do the magic inside here, and it's going to be worked out. Simplified to here, and simplified even further, and then it's going to give me 72 over 5. Then now I'm going to put back my pi there. Pi units cube. You know this time now is cube. Why is it cube?
Volume.
Volume. Very good. Once you're talking about volume, it's going to be cubic units. Once you're talking about volume, it's going to be cubic units. I saw me get it in, and I saw me get when I saw me go to school, and I saw me understand it, and I saw me again. I want you to ask me whatever that jumps out at you. I know it's the first you've seen it, it's the first of the class, but are there any burning questions that you may need to ask me?
Sir, what if the lower limit was 1 instead of 0?
No problem. It means then that you can have 4 times 1 to the 5th in this parentheses right here, right out here, so you can have 4 times 1 to the 5th plus 8 times 1 to the 4th plus 56 times 1 cubed over 3 minus 16 1 squared plus 4 times 1. Yeah, man, you can substitute it out there.
Okay, sir, that was what I was thinking. I just wanted to confirm it.
Yeah, man. So, should I tell you? No, I'm not going to tell you yet. It's very important, students, that you invest in a good calculator. It's very important that you understand how to do your distribution of one bracket over the other in order to get our 4x cubed right up here, so 4x cubed, I mean, to 4x to the 4th plus 32x cubed plus 56x squared minus 32x plus 4. If you get that wrong, best believe that the whole question may be wrong. And a question on
my calculator, sir.
Eh,
There's a button there where you can put whatever exponent you want up there. You have
Good job.
X in a box.
uh-huh.
In the box you can put whichever number you wish to put there.
Right. So you have a natural display calculator. And I want you guys to invest in a good calculator, please. Please. It will help you. Any other question?
So you
All
can
right.
scroll back
Go
down
ahead.
so and finish right also.
Say it again, Papa.
Can scroll back down?
Sure, not a problem.
No, Ramen. Up, yeah. Up to the last part. Yeah, right.
All right. So if you don't have any other questions, I just am gonna leave it, you know. And guess what? When this topic is finished, it's not going to finish just yet. Because I mean, well, if I can finish it for Wednesday, it will be great. Because as I told you, you can do the rotation about the x-axis, you can do the rotation about the y-axis. If they ask about the x-axis, it's going to be y squared. If they ask about the x-axis, it's going to be y squared. If they ask about the y-axis, it's going to be x squared. So just look out for those two little key stuff. I wish when I was going to school, teacher told me that. You had to figure it out yourself. All right? So just look out for that one. Look out about always try to remember how to distribute your brackets, and also for you to be careful of your calculation. Make sure that you transcribe the stuff properly. Make sure so when you're doing the calculation, your calculator is clear. Press off and turn on back the calculator just to ensure that you erase all temporary memory.
Sir,
Yo,
sir, before you leave, in regards to the recordings, I think you have one that is outstanding, February 12th.
yes. February
Yeah.
February 20 last week Monday.
Yes, sir, last
Yeah,
class.
yeah, last week Monday. Come never had no, and last class to right Wednesday,
Yes, sir.
Monday, Wednesday. Yeah,
So,
man, I do.
on the
I
10th, one for the 10th and the 12th.
no, hold on there. You have to, let me see. If the 10th was Monday, I would agree. Yeah, yeah, the 10th and the 12th. Yeah, man, I have those. I'm gonna send them. I'm gonna put them up tonight.
Yes,
I have those. It's just that 1 week. I don't have anything positive to tell you about Edico because I mean, I'm just sitting here waiting like all of you. I really don't have anything positive to say about it just yet. But as soon as I hear something about it, Tar and the rest of you, I will let you know. But I
So,
don't have
sir,
anything positive.
in
Go
the
ahead.
case that it don't come up in time, you will just end up start giving us graded work.
Oh yeah, man, like we did like I did in the first semester. But as I said before, if I don't hear from them pretty soon, I will need to know what I need to do. Because remember
Oh,
now, based on what it is that I saw last semester in terms of students using these solvers to solve questions, especially when I get the mid-semester test. It came out at sometimes a 90% plagiarism, because
oh,
students, you have to remember now that your teacher go conference here and teacher is introduced to quite a bit of software here. Trust me. So I know, I know, I know. So I'm saying to you, our mid semester will be as it is just now from where I'm sitting. The mid semester won't look like a face-to-face exam because I cannot afford you guys to go out there to say that you have an A for calculus or a B for calculus or even a C for calculus, and the man then give you one little something to do, and the man go say, but how will my teacher excel? Because this one I can't do, it's going to be a poor reflection on me. It's going to be a poor reflection on me. So I'm not running that risk again. And I'm going to say to you, even if I give you classwork and I run my classwork and I'm seeing a similarity index that is not favorable, I won't even give you a second attempt. Zero. Honesty is the best policy, and I don't like it. I was very annoyed in the first semester, and I just say, you know what? Let's sleep in dogs lie. It won't happen again for the second semester. But yes, I will definitely, if I don't hear anything and I feel like whatever it is, but I mean, in the meantime, yes, I can start giving you one or two because we've completed now 2 units, I believe, and I'm going to be going into our multivariable functions, which is really very nice. So by the end of tomorrow, Wednesday's class, I should be able to start my multivariable functions. All right, guys, I'm ending right there. Big up on myself. Thanks for coming out. There are some students that I am missing from my class. you know your classmates, just take a quick look at the participants list. Let me just check to see if that person is here. Right, person is not here. Just check your participants list. Make sure that your friends are here. One of the other things that I am at liberty in doing is checking the recordings to see those persons who attend my class, because I can pull students from sitting the exam if it is that they don't have an 85% class attendance. And as it is just now, some of you are here and then you're not here. I'm seeing what here? 2 students that I can quickly recognize that are absent from my class now. But anyhow, big up on yourself. Have a good one.
All right, sir. Blessings.
Yeah, man.
All right, sir. Blessings.
Easy, Papa.